Hello students, I am Ashish De. I am taking one of your subject, that is digital communication. In my earlier video, I have showed some waveforms relating to line encoding type. Okay, different types of line encoding. They are basically polar, non-return to zero or return to zero, unipolar, AMI, that is alternate mark inversion, Manchester format. So different types of waveforming I have shown in my earlier video. In this video also I want to repeat another with another example. Okay, suppose the data stream is given by this. Suppose the data stream is given by 1 1 0 0 0 0 1 and 0. Okay, so we have to draw some waveforms that are polar return to zero type, polar non-return to zero type, alternate mark inversion type, and Manchester format. Okay, so at first what we do, we have to divide the number of we have to separate the bits by a cell. Okay, so there will be this cell like this way. These are the cells of bits. Okay, now we have to draw dotted line. Okay, for each cell we have to draw the dotted line. In the half portion also we have to draw the dotted line. In the half portion we have to draw the dotted line. Okay, here is also in the half portion there will be a dotted line. Okay, here is also some dotted lines. Okay, so the dotted lines are given. Okay, now for polar return to zero type encoding, line coding, the waveform will looks like this. Okay, so for bit 1, for the first half of the bit there will be a positive amplitude, that is a by 2, right, in case of polar. And since it is returned to 0, so it returns to 0 here. Okay, in the second half. Now for the next bit, that is also 1, so here in the first half there will be a positive amplitude of a by 2, and since it is returned to 0, in the next half of the bit it will goes to 0, right. Now for the 0, for the bit 0, it will go to the negative amplitude of a by 2 and it returns to 0 in the second half. Okay, here is also 0 bit 0, so it is negative amplitude, and in the second half it will be 0. Again here is also negative amplitude and return to 0. Again it is repeated. Okay, now for 1 it will be positive peak of a by 2 and it goes return to 0. Okay, then it is 0, so it will go to negative amplitude and it returns to 0. So this is the waveform of polar return to 0, and the negative amplitude is minus a by 2. So this is time axis that is defined by small t. Okay, so this waveform is for polar return to 0 type. Okay, now polar non-return to 0 type, what will be the waveform for polar non-return to 0 type? For polar non-return to 0 type, it will be for bit of 1 it will be 1. Okay, up to this portion. Okay, again the next bit is 1, so it continues up to this portion. Okay, now this is 0, so it will goes down and it goes to negative peak. Okay, so for the next bit it will go up to this is also 0, so it is continue up to here. Now this is also 0, so it is 0, again 0, so here then there is a 1, so here will be 1 positive amplitude. So this is positive amplitude of a by 2, right? Now this is 0, so it will be 0 here, so it will be negative amplitude of minus a by 2. So this is minus a by 2 and this is a by 2, right? And this is the time axis t. So what is this? This is the waveform of polar non-return to 0, that is NRZ waveforming, right? Now the waveform is alternate mark inversion or AMI non-return to 0 type waveform. What will be the waveform? So for AMI there will be a it is non-return to 0, so for the first bit, that is 1, it will continues up to the this portion. Okay, but in the next bit this is 1, so since it is AMI non-return to 0, since it is AMI alternate mark inversion, in the next higher bit, that is next one bit, it will just invert its amplitude to A, right? So here is A, amplitude is A and this is minus A. Okay, just it inverts its amplitude, that is minus A, in the next high level value, that is 1. Okay, now since in the next bit it is 0, so it will goes to 0 here and 0 continues up to here. Okay, because there are 4 zeros. Okay, so 0 is continuous up to here this portion. Okay, now there is another 1, so for this 1, since it is in the negative amplitude, so it will just invert to positive amplitude here, positive amplitude of A. Okay, again it is 0, so it goes down to 0 level and it will continues up to here. Okay, so this is the complete waveform, this is 0. Okay, so this is the complete waveform of AMI non-return to 0 type waveforming. Okay, or alternate mark inversion non-return to 0 type. Now in the preceding waveform, that is Manchester format, in the Manchester format waveforming, as we know, for the high bit, that is when the bit is 1, then it will starts from positive half. For the positive half it is positive, and the second half it will be negative. Okay, for the first one. In the second one also it is repeated, so it will be a by 2, positive amplitude of a by 2, and this is negative amplitude, that is minus a by 2. So in the next bit also it is goes to negative amplitude, right? Now when the bit is 0, then it starts from negative amplitude and it goes up to positive amplitude. So here it is negative amplitude and it goes up to the positive amplitude of a by 2. Okay, again it is repeated 4 times. So here is also again it is repeated here positive. So here is also negative to positive amplitude, right? Now in the next bit it is 1, so it is continues up to here and it goes to negative amplitude in the second half. Okay, now the bit is 0, so it continues up to here and it goes to positive amplitude, and this is okay. So this is the waveform of Manchester format. So this is Manchester, Manchester, Manchester format. Okay, so from this video what we learn? From this video we learn how to draw waveform from a given data stream. Okay, so here the given data stream is this. Okay, so we are basically drawing some waveform, that is polar return to 0, polar non return to 0 type, again alternate mark inversion, non return to 0, and in Manchester coding what will be the waveform, that is this for. Okay.